equivalent ratios. I wasn't going to do this one, but I figured I had to because there's just nothing out there. The first exercise is filling in the blanks, so finding the unknown number. The first example is 1:4 is equal to 5 is to what? So when we do these, we think 1 to 4 equals 5 to what? The easiest way is to actually rewrite these as a fraction because remember, ratios can be written as fractions, which means they can be solved like fractions. And we can apply fraction rules. Makes it a little bit easier. But anyways, let's keep rolling through. So we write it as a fraction. We've got 1/4 is equal to 5 over blank. And then we think 1 times what equals 5? Right? 1 times 5 is 5. And do I need to say more? So then we go, well, 4 times 5. Well, 4 times 5 is 20. And then we put that into our ratio. Well, putting it in our fraction allows us to readily apply the fraction rule. What we do to the top, we do to the bottom to ratios. So what we do on one side, we do the same on the other. And then in this case, to finish writing it, we put it back into the ratio because we're dealing in ratios. Doesn't matter that we've solved it just like a fraction. We're dealing in ratios. So it needs to look like a ratio. 1:4 is equal to 5:20. These ratios, these comparisons are very much the same. Another example is where we have 3 numbers. Complete the following equivalent ratio. So once again, we're finding the blanks. So blank is to 9 is equal to 21 is to 35 is to 27. This one is not as straightforward as writing it as a fraction because there are 3 numbers. Have you ever seen a fraction that's like one number on top of another number on top of another number? No. So we're going to have to work with this one as is. Now the key with this one is to find the matching parts, and we have 9 is to 27. Remember, these are ordered. We need to make sure we keep them in order. And the question we then ask ourselves is, well, what did I do to the 27 to get 9? Or what do I do to the 9 to get 27? Now, in this case, we have the larger numbers available to us. So we're going to go from large to small, which means we're going to divide in this case. If I was going from small to large, I would multiply. Now we rewrite the ratio as we are about to work with it. Left to right, guys. Box is to 9 is equal to 21 is to 35 is to 27. And now we start to look at dividing them all by 3. Oh, wait. Hang on a minute. This example I pulled from your textbook, so I'm actually going to rework this to make it look a little better. 35 divided by 3, that doesn't actually go. You'd get a decimal. Remember, we don't want decimals when we work with ratios. So reworking the example by turning the 35 into 33 makes it much better. Oh, look, I even wrote 21 divided by 33. That's supposed to be 21 divided by 3. Too many 3s. Lots of 3s on the brain. But anyways, changing it to 33 divided by 3 makes it a little bit easier to work in so that you guys can see what's going on. Because we did 21 divided by 3 to get 7. 33 divided by 3 gives us 11. 27 divided by 3 then gives us 9. Now, there are no common factors between these 3 numbers as 7 and 11 are prime numbers. So this is pretty much as far as we could go now. If I wanted another equivalent ratio, I'd just multiply the lot by another number and I'd give you another ratio. But one thing I want to point out is simplifying ratios will also give us an equivalent ratio. Now we're moving on to creating our own equivalent ratios. I've chosen to start with 1:4 because 1:4 can easily be rewritten as a quarter, and I can demonstrate an equivalence through pizzas. I like pizzas, makes life easy. So 1/4 is a quarter. You can see that on the circle I've coloured in, 1/4. Remember, working with them as fractions, you have the fraction rule. What you do to the bottom, you must do to the top. Same deal with equivalents. I'm going to choose a number, and the first one is 2 because it's like most obvious one I think of. Then I go 1 times 2 over 4 times 2 is 2 over 8. If I were to rewrite this as a ratio, it would be 2:8. I can multiply that number by 2 again, which means I would actually be multiplying the original one by 4. So 1 times 4 is equal to 4. 4 times 4 is equal to 16. So it would be 4 over 16, giving it equivalence. As you can see by the circle, I'm technically only colouring in a quarter, even though the numbers are slightly bigger. Now, again, if this was written as a ratio, it would be 4:16.